Step into the extraordinary world of universal discoveries, where the boundaries of scientific understanding are pushed beyond imagination. Can you fathom a future where we no longer ponder the mysteries of space in mere wonder, but voyage through the cosmos on spacecraft hurtling beyond the speed of light and sound? Get ready to be astounded as we dive deep into the remarkable findings that have unveiled new means of travel, a way to journey faster than light itself. In this episode, we unveil the groundbreaking discoveries of scientists who have uncovered a path to travel at unimaginable speeds, transcending what was once deemed the ultimate limit. The future promises an era of astounding possibilities, and together, we will set forth on a journey that will reshape our perception of the universe. Join us and quench your thirst for knowledge. In the history of aviation, few names evoke the same sense of wonder and speed as the Concord. This supersonic plane, with its sleek, tapered fuselage and slender wings, cut through the skies like a bird of fire, challenging the limits of physics and taking people to new destinations at incredible speeds. As we travel back in time, we find ourselves in the skies of Paris. It is March 2nd, 1969, and the Concord is about to make its inaugural flight from Paris to Rio de Janeiro. This event marks the beginning of an era of supersonic flights that will forever change the way we see the world. The Concord was a revolutionary plane that could reach speeds greater than Mach 2, about twice the speed of sound. This meant it could cross the Atlantic in just 3.5 hours, turning a transoceanic flight into a short trip. Passengers could have lunch in Paris and dinner in New York, experiencing a unique moment in their lives. But the Concord was not just a fast plane. It was also a work of engineering art. Its design had required years of research and development, challenging the limits of the technology of the time. Its tapered wings had been designed to withstand aerodynamic stresses at supersonic speeds, and its engines were among the most powerful ever built. The Concord became a symbol of excellence and progress in the aviation industry. It was a milestone in aeronautical engineering, proving that humanity could overcome physical barriers to reach new heights of speed and performance. Today, the Concord has fully entered the history of aviation. The plane's last flights took place in 2003, marking the end of an era. But our desire to explore the sky and space has never waned. We are driven by the desire to reach new frontiers, to overcome previously insurmountable limits. We now enter a different world, a world where space travel becomes our next frontier. But there's a problem: the speed of light. According to Einstein's theory of relativity, nothing in space can travel faster than light. This means that even with current technology, it would take us millennia to reach the nearest star system. The question arises naturally: why is this so? Einstein provided a clear explanation in his equations of general and special relativity. Matter, which includes us and the objects around us, cannot even approach the speed of light. This is because the equations of dynamics and energy requirements behave anomalously at such speeds. But humanity does not easily give up in the face of seemingly insurmountable challenges. Our scientists have worked hard to solve this puzzle. They have tried to bend space and time to our advantage, creating a spaceship capable of exceeding the speed of light. This concept is well known to science fiction enthusiasts, thanks to the iconic warp drive. In science fiction, the warp drive was popularized by authors like John W. Campbell and Gene Roddenberry, creator of Star Trek's Enterprise. But science began to take this idea seriously in the 90s, trying to overcome the challenges posed by Einstein's theory of relativity. The warp drive is based on creating a warp bubble that allows the spaceship to travel faster than light. This concept may seem complex, but its essence is quite simple. It's about creating a kind of fold in space and time, in which the spaceship moves without having to exceed the speed of light. The occupants inside this bubble will perceive a smooth journey, without having to face the physical challenges of acceleration. But what would Einstein say about all this? His theories of relativity, which have laid the foundations of modern cosmology and physics, seem to be violated by this idea. However, Einstein remains unscathed. Special relativity asserts that energy and mass are interchangeable, but travel at light speed remains impossible for objects with non-zero mass. This means that reaching the speed of light would require infinite energy. In 1994, a Mexican physicist named Miguel Alcubierre took on this challenge and found a theoretical solution. He used Einstein's theory of relativity to develop a framework that would allow faster-than-light travel, at least theoretically. The key to his idea was to create a bubble in space-time, which would allow the spaceship to exceed the speed of light. Miguel Alcubierre, a brilliant Mexican physicist, laid the groundwork for one of the boldest ideas in the field of space travel. In 1994, during his doctoral studies at the University of Wales, he developed a framework that challenged Einstein's theory of relativity. His ingenious idea was to create a warp bubble in space-time that would allow the spaceship to exceed the speed of light, at least theoretically. But how would this warp bubble work? The idea is quite simple and, at the same time, revolutionary. Alcubierre proposed creating a localized distortion in space-time behind the spaceship and a contraction in front of it. This process would allow the spaceship to move faster than light, while inside the bubble, the occupants would not experience any significant acceleration. Imagine sitting inside a spaceship equipped with a warp engine. As the engine turns on, the world around you begins to distort space and time. Your spaceship seems to disappear from the sight of earthbound observers, and only a bright white light marks its passage. The occupants on board only feel a slight vibration. In a few moments, your spaceship can cover cosmic distances that would otherwise take millennia to cross. It's as if you wanted to travel from one star to another in the blink of an eye. This is the magic of the warp drive, overcoming the limits imposed by Einstein's theory of relativity and making interstellar travel possible. But there is a crucial problem to solve: the energy needed to power the warp engine. How can we accumulate enough energy to distort space to such an extent? At the moment, with known technologies, it would seem impossible. An energy equivalent to the mass of Jupiter would be required to reach such powers. However, research has not stopped. Scientists are exploring new possibilities to overcome this energy challenge. One of the most promising solutions could be the use of antimatter. Antimatter is an exotic substance with negative mass and energy density. If we could capture and use antimatter, we could have access to an incredibly powerful energy source. The problem, however, is that antimatter remains an enigmatic and poorly understood substance. Its existence has been theorized, but so far has not been convincingly demonstrated. Capturing and stabilizing antimatter would require technologies and knowledge beyond what we currently possess. But science is not made to surrender. Research on the warp drive continues, driven by the need to overcome the barriers of space travel and to explore the universe in ways never before imagined. While the Concord brought humanity to the sky with supersonic speeds, the warp drive could be the key to taking us beyond our solar system and discovering new worlds. At the moment, our spaceships only reach a small fraction of the speed of light. The fastest space probes, like Voyager 1, took nearly 35 years to leave the solar system and are over 21 billion kilometers from Earth. It's clear that with current technologies, even relatively close distances in space remain a monumental challenge. As we explore the challenges of space travel at speeds close to that of light, we encounter a glimmer of hope in the darkness. Scientists around the world are tirelessly working on innovative solutions, making progress every day. Recent experiments in particle physics laboratories are opening new perspectives. Theories about dark matter, exotic particles, and hidden dimensions are emerging, sparking interest among experts. If these theories could be successfully applied, they could offer a key to overcoming the speed of light in ways that currently elude our understanding. Research continues, fueling our hope of conquering the final frontier of interstellar exploration. This glimmer in the darkness could be the prelude to a new era of cosmic discoveries and adventures in the universe. In the heart of one of the world's most advanced research laboratories, scientists are engaged in an extraordinary investigation into the potential key to overcoming the speed of light: antimatter. Antimatter is a substance composed of antiparticles, a kind of counterpart to the particles of matter that make up our universe. In this ultra-modern facility, researchers work with gigantic particle accelerators to generate and study antimatter. The goal is to understand how to control it and exploit it for space propulsion purposes. Antiparticles like positrons are known for their peculiar behavior when they come into contact with matter. The idea behind this research is to create a form of propulsion based on the controlled annihilation of matter and antimatter. An extremely powerful process that could theoretically allow the spaceship to overcome the barriers of the speed of light. However, controlling antimatter and controlled annihilation are enormous challenges that require highly advanced technology. Antimatter is a fascinating and mysterious concept that has tickled human curiosity for decades. Since its theoretical prediction in 1928 by Paul Dirac, scientists have dedicated themselves to searching for traces of antimatter in the universe and understanding its nature. Now, in the modern era of science and technology, our understanding of antimatter is making leaps and bounds. In advanced research laboratories, scientists and engineers are working tirelessly to generate, capture, and study antimatter. The goal is to understand how to manipulate these antiparticles for practical purposes, such as space propulsion. The key to overcoming the speed of light may lie in the controlled annihilation of matter and antimatter. When a particle of matter comes into contact with its antimatter counterpart, an annihilation reaction occurs. This process releases an incredible amount of energy, much more efficient than any form of propulsion currently available. However, the controlled annihilation of matter and antimatter is an unprecedented challenge. It requires the ability to generate, store, and release antimatter safely and efficiently. Moreover, it should be done in a manner that allows precise control and directionality in thrust production. In the heart of these laboratories, gigantic particle accelerators and advanced detection chambers are revolutionizing our understanding of antimatter. Scientists are close to developing the technologies needed to manipulate antimatter, thus opening new perspectives for the future of space exploration. The Concord was an icon of aviation, a symbol of speed and human ingenuity. But humanity is destined to look beyond the earthly skies and towards infinite cosmic space. The warp drive represents our ambition to overcome the limits of the speed of light and embrace the future of interstellar exploration. Despite the challenges that await us, the desire to discover new worlds and to overcome physical barriers remains a beacon guiding our path in the universe.